Good morning. My name is Vipul Das, and this is my submission for the Sparks Foundation Internship Program, Task 2, titled Prediction Using Unsupervised ML. This unsupervised ML clustering is meant to be performed on the IRIS dataset. The IRIS flower dataset is a multivariate dataset introduced by British statistician Ronald Fisher in 1936 and used by him as an example of linear discriminant analysis. What this means is that this dataset is an already labeled dataset with predefined target variables, but for our purposes, we'll pretend that this dataset is unlabeled and perform a clustering analysis on the dataset. Once again, import the libraries and import the data as necessary, then check for any null values and ensure that the input features are all in the required data type. As part of EDA, I present to you some scatter plots detailing various features against each other. Only for the first draft, I've included the output column, i.e. species, as hue here. So when plotting sepal length versus sepal width, each data point will be color-coded according to its species. There's a clear indication of clustering with some overlap here. As you can see, blue for Iris setosa, orange for Iris versicolor, and green for Iris virginica. Similarly, sepal length versus petal length also points to some clustering, as does sepal length versus petal width. We're finally going to create the model. I've dropped the species column here and made this data truly unlabeled. All features are relevant and thus are included as independent variables. We'll be using k-means clustering to cluster this dataset. Part of k-means clustering involves choosing k, or the number of clusters the dataset is to be divided into. There's no way to discover an optimal value of k other than to run the clustering with multiple values of k to discover an optimal value. So that is what we're going to do. This method of determining the optimal number of clusters is titled the elbow method, since the point at which the information gain falls off steeply is the number of clusters we want to pick for our dataset. We determine that number to be 3, which is consistent with our exploratory data analysis. We run the clustering with 3 clusters, then fit the features and predict the outputs, and store these outputs in a variable. The sum of squared errors is also stored in a different variable. I finally add these predictions to the data frame. For comparison purposes, I've created 2 graphs here. Both plot sepal length versus sepal width. But the first graph uses the actual species classification to color code the data points, while the second graph uses our classified outputs to color code the data points. You'll notice some discrepancies here and there, specifically around, for example, this point and this point. As you can see, all 4 points over here are of the orange variety, while over here there's one green data point here. This is our predictive ML output. And that is it for task 2. Thank you.